Swayam Prabha. Digital India. Educated India.
What is the meaning of this linear operator? I said linear operator. So, A psi, when this acts on this, I get a new g of x. Alright. This psi, I write it as a linear combination psi 1, C1 psi 1 plus C2 psi 2. So, this will become C1 A psi 1 plus C2 A psi 2. Therefore, this operator acts linearly. Therefore, this is called a linear operator. Clear? You got the idea what is a linear operator here. So, this the function that I have is C1 psi 1 plus C2 psi 2. Alright. So, this linearly acts. So, first it acts on psi 1 and then it acts on psi 2 and then you have sum. Therefore, it is C1, C2 are the constants, therefore, it may not act. We have seen in the differentiation that d by dx of 4x is 4 will come out and you will have only the d by dx of x, therefore, it is 1. So, something similar to that C1 will come out in the scalar multiplication. Only this operator A acts on psi 1, psi 2 acts on this A, therefore, it is linearly operates. Right. So, we have seen rules, right, or postulates. Another is what is another postulate is expectation value. What is expectation value? I am sure you are all familiar tossing a coin, right? You have calculated in statistics in +2 random variables and then you have calculated the average and so on. You toss a coin, right? So, one time I will get head, another time I will get a tail, head, tail. What is the average? Whether I get tail or head, that is the expected value, right? Therefore, yes, similar to that, because you must have studied in basic quantum mechanics that the probability, right? I have written integral psi star psi is the probability of finding a particle. Therefore, in the some aspects of mostly all the aspects of statistics is borrowed to understand the concepts in quantum mechanics. So, you give a probabilistic interpretation of the wave function. Therefore, this expectation value is also derived from that. It is nothing but we know that it is something similar to the average value. So, you can define the expectation value. This is also another postulate which tells you that the expectation value they put in this kind of a bracket. This is equal to integral psi star operator psi beta. This is the expectation value of the operator. So, let me summarize, right, whatever that I have discussed. Though I have not done in some order because I thought that I will start with operators and then go on operator algebra. I understand that the fundamentals of quantum mechanics have not been discussed. All right, that is why I have to give you some basics. So, in summary, what we have seen in the last half an hour, 45 minutes, right. So, I have introduced the postulates of quantum mechanics. Postulates of quantum mechanics. I defined the state of the system. Psi is the state of the system. Second, superposition principle, that if the same state is represented by psi 1 and psi 2, then state of the system can be represented as a linear combination C2 psi 2. Third, right, we discussed about the probabilistic interpretation, integral psi star psi d tau. This is also equal to modulus square of d tau. S1 gives you the total probability. Then I defined a linear operator, A operator, A. Generally, this is represented in terms of position and momenta, and this is equal to, I put it in the operator notation, x is x scalar minus IH cross del is the corresponding differential operator. The linear operator idea is, suppose psi equal to C1 psi 1 plus C2 psi 2, then A psi equal to C1 A psi 1 C2 A psi 2. This is the linear operator. Fifth point that you have to remember is expectation value. Integral any observable A and its expectation value is given by integral psi A psi d tau. I have equivalently defined the Dirac notation. The wave function psi x comma t is represented as psi with this bracket notation. In a simple sense, the corresponding complex conjugate is represented like this, bracket notation. All right. The integral psi star psi d tau is written like this, psi equal to 1. This is in Dirac notation. Same expectation value, integral psi star A psi d tau is represented as right. This is a notation. I think you have to learn this notation, Dirac notation. Right. Today, go to room, Google it, Dirac notation. So you can easily pick it up. Right. Clear? Any questions? Anything? Anything, Thambi, you want to ask? You have to learn. What is the next point that I discussed? The other point that I have discussed is A and B are two matrices. Then I asked you to work out the product A and B A. We have worked out this product and we found that AB is not equal to BA. Alright. Then I said that seventh point, all operators are represented as matrices. They can be represented by operators or operator is represented as a matrix. Therefore, if I have two operator, A operator, B operator, and B operator, A operator, this product, right? A operator is not equal to B operator into A operator. This is not equal. Therefore, this is called AB minus BA. This is called commutator bracket. It's called commutator bracket. Commutes means what? When A into B equal to B into A, meaning that it commutes. The two operator commutes. Right? AB equal to BA, therefore AB minus BA equal to 0. It's called commutes. Then the point that I have discussed is position is an operator, the corresponding is a scalar multiplication. Momentum is an operator, corresponding operator is minus IH del. I wrote R vector can be written as xi plus yj plus zk, right? P vector is written as px plus py plus pz, right, like that. And I have also written that right, this, therefore del I have written as I dou by dou x, j dou by dou y plus k dou by dou z. Therefore, what is the operator corresponding to px? Px is minus ih cross dou by dou x. Py is minus ih cross dou by dou y. Pz is minus ih cross dou by dou z. Overall, P is represent ih cross del. Del is this operator I dou by dou x, j dou by dou y, k dou by dou z. And P will have a x component, y component, z component, that is px, py, pz. Alright, py, pz. Right. Correspondingly, this is dou by dou x, this is dou by dou y, and this is dou by dou z. Therefore, px operator is minus ih cross dou by dou x. Py operator is this, pz operator is this, right. Now I define, right, operator, define an operator, right, d equal to x into px. I define operator d equal to x into px, and psi of x is the function. D is this operator, psi is this function. Now calculate this value. Quick. I have defined everything to you. So I define a differential this is D is a differential operator, that is equal to x into px. And what is px? You know now, yes or no? Right. So I define a wave function psi of x. Calculate d of psi of x. My handwriting is clear? No issues. Anybody has done? Quick. So what is D operator now? The D operator is x into px I said. Therefore, x into minus IH cross. Therefore, minus IH cross x dou by dou x. So, this is the operator and psi is going to act on this. So, minus IH x dou psi by dou x. This is the D operator. Now, you change this, right? You call it as D1. D2 operator is Px x. Calculate the value. So, Px is minus IH cross dou by dou x into x on this psi is going to act. So, this will become minus IH cross dou by dou x of x into psi. So, this is minus IH cross uv rule du v into du by dx plus u into dv by dx. Therefore, this is x into dou psi by dou x plus psi into dou by dou x, it is 1. Therefore, this will be minus IH cross x into dou psi by dou x plus psi. Now, what is this? This is nothing but x comma px minus px x. What is this quantity? What is this? This is commutator. Yes or no? Right. Now, find the value. So, this is nothing but x comma px commutator is xpx minus px x. This is what I am trying to evaluate, right? This quantity, the first quantity is xpx. Xpx is minus I h cross x dou psi by dou x. This is minus of plus I h cross dou psi by dou x plus I h cross psi. Correct? Right, ma? Right. Therefore, what is the answer that you are getting? X comma px equal to this goes psi equal to IH cross psi. Therefore, x comma ps is IH cross. Right? I am sure you must have done this in your MSc. You have done or not? You have not done this. Okay, this is called commutator x comma px, and x and px are called conjugate coordinates. X and px is called canonically conjugate coordinate, x and px are conjugate coordinates. Clear? Now I will give you an exercise. The exercise, what you have to do is x comma px square. Evaluate this x comma px square. Evaluate the commutator bracket x comma px square. 10 minutes. Anybody is willing to do it on the board? Can you try on the board? Would you like to try? Who is going to try on this board? So what is the answer? Would you like? Who is going to try? Can you come and try on the board? Come, come, come. Huh? Was done. So to understand this, there are some simple postulates or simple equations. Now I will give a hint. Try this. Now we have defined A comma B, two operators, right? We have two operators A and B, and then we have defined the commutator of this operator is AB minus BA. We have defined that. Now suppose I have three operators, right? I have AB comma C. So two operator, this is product, and this is a single operator. So when I have this, what is the answer? The answer is A into B comma C plus A comma C into B. So this is one rule. And A comma BC. What is this A comma BC? This is commutator of AB times of C plus B times of commutator of A times of C. Alright. I am not going to prove this, it is a very simple proof. Alright. So this is the rule that you can use to calculate this x comma px square. Try with this rule. So you can also use the d by dx notation and then try. You can also use this rule to calculate that. So how do you take this? Now I try for this x comma p square, x comma p square can be written as p times of x comma p plus x comma times of p. What is x comma p? X comma p is, this is I h cross times of p, this is I h cross times of p, therefore it is 2I h cross p. Alright. And what is x comma p cube? X comma p cube. Three I, excellent. 3I h p square. So what is x comma p n? Ni? Yes, it is I h cross n p n minus 1. So you can generalize. Now it is an important quantity. Try to evaluate this. Evaluate x px square. Quick. This is the last exercise today. After that you can go for lunch. Evaluate x px square. Understand, try to understand that this is square and we have x comma px. No, I am not telling anything, you try. Generally we write x into x is x square, right? But these are all operators. Think about that. So since these are all operators, this is not equal to x square px square. Since these are all operators, it is not x square into px square. And evaluate, quick. Huh? 2I? No. Would you like to try on the board? Hook? No, it will be videographed. No, it will be throughout the country, it will be shown. It. Try, let's attempt together. Come. So this is, I'll just give a hint. X px square equal to xpx into xpx. So this can be written as x into xpx minus IH cross xpx. Px. Alright. Here I am using the commutator of this, commutator of x comma px equal to IH cross xpx minus pxx equal to IH cross. Alright. I am using this pxx in terms of this, alright, and then writing that. Alright, and then evaluate. So this, still if you have a problem, pxx equal to IH cross xpx minus IH cross, therefore I am substituting that here. So what's the answer? So this is x times of xpx minus IH cross px. I will write only the final answer. You work out the algebra. X square px square minus IH cross xpx. That's the final answer. You have to work out. So if you are thorough with this, then I write this x dot p square equal to x square p square. Again these are all vectors minus L square plus IH cross x dot p. All these are vector. Show that where L is the angular momentum. Here I have defined L. L vector is R vector times of P vector. Angular momentum, how do you define angular momentum? So I defined L equal to R cross P. You are all familiar. Angular momentum is defined as L equal to R. Vector algebra +2, right? And this vector you have evaluated this vector in your +2 vector algebra. L equal to R cross P, cross product. R vector is xi plus yj let zk. P also will have a vector pxi, pyj, pzk, alright. Therefore, R cross P, L equal to I, J, K, X, Y, Z, Px, Py, Pz. Alright, this is equal to I into Ypz minus Zpy minus J cap into plus K cap into this. This quantity L vector is represented as Lx plus Lyj plus Lz K. So, you will have Lx, Ly and Lz. Angular momentum is another important operator in quantum mechanics. So, in the last 2 hours what I have introduced you is operator concepts in quantum chemistry or quantum mechanics. Alright. In fact, I should have started differently, but we discussed and started this. Alright. Therefore, I have introduced what are operators in quantum mechanics. In fact, I can start from the Schrodinger equation, write the operator and start the maybe in the next class. Alright. We'll start with the Schrodinger equation and then start discussing, but we'll spend some time on this angular momentum algebra. Alright. So, the commutator algebra is nothing but the algebra involved with the operators. Therefore, it is called commutator algebra. Alright. You have seen that x comma pn. Similarly, you can also have p comma xn. Alright. So, these are the important commutator brackets that you come across in quantum mechanics. So, one of the important operator in quantum mechanics is angular momentum, right. Most of the problem that you will see in hydrogen atom or rigid rotor, right, all these are angular momentum. I am sure that Professor Mangal Sundar would have discussed about the rotational spectroscopy, yes or no? He discussed, right? Mangal Sundar discussed through the online, right? Then you would have discussed rigid rotor, alright. So, rigid rotor is important operator in spectroscopy in quantum mechanics. Therefore, tomorrow in the next class we will work out the operator algebra of this, and then if time permits we will take harmonic oscillator in this algebraic aspect. Okay, I stop here. If you have any questions, kindly ask me, we can discuss. Okay, any questions? Clear? I am not a good teacher, I know that. I am a very bad teacher, right? I can only speak to the board, right? Not to the students, right? If you have any questions, kindly ask me. Otherwise, we'll stop here. Okay. Thank you all.
SwayamPrabha, Digital India, Educated India.